Hello friends, welcome to this session. Today we are going to discuss a very important yet interesting topic. Look at these images on the screen. Have you ever wondered how it works? Do you find anything common between them? Yes friends, all of these things works on electricity. And what else? Now how exactly does it work on electricity? What tends to convert this electric energy into mechanical energy? So friends, you don't have to worry at all, as we are going to answer to all your questions. Have you ever heard about the word motor? Yes friends, you are right. Motor is the machine that produces motion or power for doing work, such as motorcycle. But you must be wondering how it connects to electricity then. Okay, let's have a look at these images again. Do you find anything else common between them? The common aspect is that they have a certain part which rotate. But how does it rotate? Yes friends, here the process that is responsible for this rotation is called electromagnetic induction. So what do you mean by electromagnetic induction? Electromagnetic induction is the production of voltage or electromotive force due to a change in the magnetic field. And it was discovered by Michael Faraday in the 1830s. The machines like generators, transformers, also the motors work on the principle of electromagnetic induction. So friends, let's discuss one of the applications based on electromagnetic induction, that is a DC motor. Yes friends, direct current motor. It transforms electrical energy into mechanical energy in the form of rotation. DC motor have inductors inside which produces the magnetic field used to generate movement. Now in this animation, you will find a very simple schematic of electric motor. As you can see, current is flowing through the motor and motor is rotating in anti-clockwise direction. Now let's see the process in detail, that how the motor is able to rotate. Now let's look at the top view of the direct current motor. From top view, you will be able to understand the construction of motor in an easier way. As you can see, there are two magnets inside the motor, North Pole and a South Pole. And within these poles of the magnets, there is a rectangular coil A, B, C, D. Now, two ends of this coil A and D are connected to the split rings. Now, why is it called split rings? It is so called because, as the name suggested, there is a split. Now, if you will take a ring and you will split it like this, you will see two parts of a ring like this. So, in the same manner, the ring is placed here, which are connected at the end of the rectangular coil, that is at A and D. Now, S1 and S2 is touched to the carbon brushes B1 and B2. Now the function of these carbon brushes is to make contact with the rotating rings and through them to supply current to the coil, and also makes sure the commutation process remains free from sparks. Now this is connected to the battery across which the entire circuit is connected. Now on the polarity of battery, the current will flow in this manner. Now if you will consider these arms separately, that is arm AB and CD, you will find that the flow of current in both these arms is perpendicular to the direction of external magnetic field. Thus, there will be a certain force that acts on them. And if you see the flow of current for the arms BC and AD, it is parallel to the direction of external magnet. So due to this, there will be no force that acts on them. Now we will consider arms AB and CD, and we will see how we can calculate force on them by using Fleming's left hand rule. Now what exactly is the Fleming's left hand rule? It is found that whenever a current carrying conductor is placed inside a magnetic field, a force acts on the conductor in a direction perpendicular to both the directions of the current and the magnetic field. Let's pause the simulation to understand the flow of the current better. Now let's have a look at the arm CD. The flow of the current is like this. Now first, consider the index finger pointing in the direction of the magnetic field. Now outstretch the middle finger pointing in the direction towards the current flowing through arm CD. Now stretch out the thumb such that it is perpendicular to both the index finger, that is the magnetic field, as well as to the middle finger, that is current. We will find that this gives us the direction of force acting on the arm CD. Thus, we can say that according to Fleming's left hand rule, the force acting on arm CD is in upward direction. Now if you will observe carefully, there is one small problem here. Okay, now let's take the example of coil. Now if we want that our coil should always rotate in anti-clockwise direction, then the force on the right side should be in the upward direction, and on the left side the force should be in downward direction, right? But if you will observe here, if we rotate the coil on half rotation, on left side the force is in upward direction and on the right side the force is in downward direction. That means the coil will start rotating in clockwise direction. So now you will observe the coil will rotate clockwise and anti-clockwise. Then how exactly the motor that works as a coil is not completing even one rotation? So friends, if we want that the coil should rotate in anti-clockwise direction, for that we will have to change the direction of force on left side. So how is that possible? Now friends, observe here carefully. If we want the force in downward direction, by keeping the flow of current in same direction, then eventually we will have to reverse the direction of magnetic field, for which we will have to reverse the position of magnetic poles, which would not be possible every time. So the next option is by reversing the direction of current, which will look like this. Now the force is acting in downward direction. So we will reverse the direction of current throughout the coil, then the coil will rotate in anti-clockwise direction. But you must be wondering how we will reverse the direction of the current. So friends, here if you observe carefully, there is a split ring commutator. Whenever the coil passes from the vertical position, the direction of the current through the coil has to be reversed so that the coil continues to rotate in the same direction. Hence, the two parts S1 and S2 of the split ring are used to act as a commutator to reverse the direction of current in the coil. So, they are called as split ring commutator. Now you can observe here that the current flowing through the arm CD and AB is same because it is connected to the same battery, and also it is kept between the same magnets. Therefore, the same magnetic field acts on them. Thus, we can say that the force which will act on them will also be equal but in opposite direction, that is in upward, and the other in the downward, and also not along the same line of action. So it forms a couple which causes the coil DCBA to rotate in anti-clockwise direction. Now if we change the polarity of the battery, let's see what would be the movement of the coil. Well, we can see here the coil will rotate in clockwise direction. Okay, now what if we change the polarity of magnets? Let's see. Well, we can see here the rotation of coil will get changed. Now, magnet can either be in the shape of a bar or a horseshoe. So friends, if we want to increase the efficiency of this motor, so what do you think are the factors which will affect on it? Yes friends, there are these three factors: the applied voltage, the flux, and the voltage across the armature. Friends, the speed of DC motor is directly proportional to the applied voltage and directly proportional to the magnetic field strength. So, if we increase the voltage of the battery, then the number of turns or rotations of the rectangular coil will also increase. And if we increase the strength of the magnetic field, then the number of rotation will also increase.
Subscribe now and press the bell icon. Never miss an update.